Hello, in this video we are working through example 4 in section 6.1 and we are now talking about the repeated use of integration by parts, which we are going to see in this example. So to begin with, we have to choose u and dv. Remember, we are going to use ILATE or LIATE works as well. We have an algebraic function here, so that means we have an a, and then we also have a trig function, so that means we have a t. So we're going to pick the algebraic function to be u and the trig function to be dv. Hopefully this will work out. If not, then we will move around some things like what we saw in the previous example in exercise 1. But we'll start off with letting u equal x squared and dv equaling the sine of x. Now the question comes, can we integrate dv? And I'm sorry, we need to include a dx here with the sine of x. So can we integrate the sine of x dx? And the answer is yes. This is a direct antiderivative. Specifically, the integral of sine x is equal to negative cosine of x. Then we differentiate u, and that is equal to 2x dx. So then the integral of x squared sine x dx is going to be uv. So that's going to be a negative x squared cosine of x minus the integral of v, negative cosine x, du, which is a 2x dx. We'll go ahead and simplify first before trying to evaluate that integral. 2 negatives gives us a positive. We can rearrange to get a 2x cosine of x dx. Now from here, we still have a product of functions. We have a 2x and a cosine x. So we will need to use integration by parts again. And before I continue, I do want to make one more comment here about rewriting this integral. For those of you that like to move constants outside of integrals, that's still perfectly fine to do with integration by parts. So if we did that here, we would end up with a negative x squared cosine of x. Sorry, that should be a c there, cosine of x, plus 2 times the integral of x cosine of x dx. Notice we still have a product of functions here, so we're still going to need to use integration by parts. The 2 is just now outside of the integral, so it's not going to go into the choice of u and dv anymore, but it is something that we'll have to remember to multiply by later. So I'm going to go ahead and continue with doing it this way. Again, we have an algebraic function and a trig function, so we're going to let u be equal to the algebraic function and dv equal the trig function, so that's cosine of x dx. Notice I am reusing the u and the dv here. So previously I've said that if you use a substitution, you have to use a letter other than a u, because u is already being used for integration by parts. If you want to, you can use letters other than u and dv here for the second time that you're using integration by parts. But the reason why I'm reusing the u and the dv is because we're already finished with this first time of integration by parts. We're not going to use those things again. So if we reuse the u and the dv, it's not confusing. We're just going to reference the last time it was used. If you use a substitution inside of integrating your v, then you need to use a letter other than u because this u is still in play. So you would use something like a w, like what you would have seen in the solution to the previous example, that exercise 1. Now I am done with the first u and dv, so I'll just go ahead and reuse them here. So I'm going to differentiate u to get a dx. I'm going to integrate v. The integral of cosine of x is sine x. So now we rewrite our first term, negative x squared cosine of x. Notice that tracks down. We also need to rewrite the plus 2 part. And now I'm going to put stuff in parentheses because I'm going to have 2 terms that I'm going to substitute in here. Remember, integration by parts is a uv minus the integral of v du. So I'm going to have 2 things that I'm going to write in here to replace this one integral. Since this integral got multiplied by 2, that means that both of these terms now need to be multiplied by the 2. So I'm going to have a u and a v, that's x sine x, then minus the integral of v du, that's sine x dx. Notice that this is no longer a product of functions. We can evaluate that. The integral of sine x is negative cosine x, so when we combine it with that negative, we'll get a positive. So if we rewrite this, we have negative x squared cosine of x plus 2x sine x. Then we'll have minus the negative to give us a plus 2 cosine x. We are done with our integration now. It is an indefinite integral, so we need to remember to add c. And I'm just going to go ahead and rewrite what we have on the left-hand side for our final answer. The integral of x squared sine x dx is equal to negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. And this is how we would apply integration by parts multiple times. In this example, we applied it twice, but you can hopefully see that if we would have a product of functions here, we could simply apply integration by parts again and again and so on. Just a quick rule of thumb, at least for my course, anything graded, you will not need to do integration by parts more than 3 times, okay? So I will restrict it to that. If you ever get something where you've applied integration by parts more than 3 times, then that's an indication that something went wrong somewhere. So look back over your work. In general, you may, some integrals can require integration by parts to be used more than 3 times, but for my course, anything that you will need to do can be completed in at most 3 uses of integration by parts.